24 hours a day, the Goonie Bird, relics of World War II, fly electronic snooping missions over South Vietnam and Laos. Fondly dubbed the Antique Airlines by the men of the 360th Tactical Warfare Squadron and the 6994th Security Squadron, these aircraft under the code name Combat Cougar are providing a highly effective electronic warfare system for locating frontline enemy transmitters in the Vietnamese War. Lieutenant Colonel Alan B. Thomas has this to say about their mission.
Our job is to conduct airborne radio direction finding operations against the enemy transmitters in the field, to gather intelligence from their transmitters, and while airborne to relay this information to U.S. field forces. Our parameters as specified by MAC-V are accuracy, timeliness, and quantity. We strive first of all to position the fixes as accurately as possible, and this can be done to as close as 250 meters. Secondly, to rapidly pass the fixes to our field force customers, and thirdly, to get as many fixes as possible in a 7-hour flight.
1 hour and 15 minutes before takeoff, the crew receives a classified briefing. Intelligence, en route weather, operational data, scheduled times, and emergency procedures. The navigator and DF operator pass on to the crew the initial Doppler set point, heading to the assigned area, and information about the radio activity to be expected. The general location of enemy transmitters and specific targets on which friendly commanders have requested priority information is also passed on, as well as potential visual reconnaissance points. The C-47's minimum crew consists of pilot and co-pilot, the flight engineer, a navigator, and 2 DF operators. All must work closely together at all times, as the premium on teamwork is extremely high. "45 minutes before takeoff, the crew performs a normal pre-flight inspection of the aircraft. At 25 minutes, the engines are started. Immediately after takeoff, the initial Doppler settings are made using a set point, which may be as close as 5 miles. Benoit Bridge, for example, is frequently used for this purpose. Once the aircraft is airborne, the pilot levels off and warns the navigator at about 3 miles from the selected set point. The navigator, sighting through the drift meter bomb sight fashion, directs the pilot to maneuver the aircraft directly over the set point for a visual fix. When visual sightings are not possible because of marginal weather, ground-based radars are used to establish position over the set point. This, of course, is not as accurate as the visual set. En route to the target area, the Doppler accuracy is verified against another selected set point, and the search for other targets of opportunity continues. Aircraft normally fly their day-night missions above 3,500 feet to avoid small arms fire. Descents to 2,000 feet to avoid clouds are occasionally made, but because of the nature of the equipment on board, flying below this altitude is not authorized. Once over the target area, the main job falls to the navigator and the 2 DF operators. Doppler accuracy is again verified on another set point and reset if necessary to give the most accurate information over the target. Working as a team, the navigator and DF operators concurrently feed data to what could be called a 4th member of the team, the printer. One DF operator searches for enemy transmissions. Although he will concentrate on certain pre-briefed frequencies, he must also scan the whole spectrum for unanticipated targets. With the desired enemy transmission displayed, the DF operator locks on and notifies the crew over the intercom with "lock on," and then gives the signal strength reading. At both the navigators and pilots panels, the lock-on lights illuminate, and the ARDF swings to indicate the enemy transmitter's bearing. At this point, the pilot must maintain level flight so that accurate readings may be obtained. Once the navigator has determined that all the displayed information is correct, he initiates a printout which combines the aircraft's position and time with the frequency, bearing, and strength of the enemy signal. Selecting the best combination of information from the tape, he uses this to plot the aircraft's position and bearing to the transmitter, thus giving him the first line of position, or LOP. Now the aircraft is flown into an area of stronger signal strength, and the same procedure is repeated for a second and third time, resulting in a fix. Verification is again made by checking the Doppler accuracy against the initial or another set point and correcting for any accumulated error. Meanwhile, the flight engineer is busy dropping Chewy Hoy leaflets to cover the real purpose of the mission. He also observes the ground for any unusual activity. Typical of an incident was the spotting of enemy troops along a road. A forward air controller was requested, found unavailable, so the Artillery Control Center requested the aircraft to serve as artillery coordinator. Mission experience has shown that the optimum flight path for ARDF operation is a straight line. This requires the aircraft to be in position to receive an optimum signal from the enemy transmitter, thereby causing the ARDF needle to swing rapidly. When a minimum signal has been picked up, the aircraft is flown directly toward the target until the signal strength increases to near maximum. The closer the approach, the stronger the signal, and the further off the nose the pilot maintains the bearing. Thus, the cone of silence over the transmitter is avoided, which would cause the ARDF needle to spin or hunt, producing incorrect readings. Frequently, only 2 lines of position can be obtained before the transmitter goes off the air, but we don't disregard this information. In this case, we proceed to the next desirable LOP location. Then, if the transmitter starts to send again, we are in a position to obtain the third LOP and complete a fix that might have otherwise been disregarded. By flying a straight line path, there are no telltale maneuvers to alert enemy operators or ground observers to the purpose of our mission. Experience has shown that this procedure results in an ideal LOP with good angular separation. The straight line path also is the easiest to execute and employs the full 360-degree capability of the equipment. The ultimate goal of Combat Cougar is to provide our ground forces with enemy movement information in sufficient time to react effectively. For experienced crews, less than 10 minutes is not unusual. Fast reaction time, aided by electronic surveillance, is enabling our forces in Vietnam to counter the enemy punch for punch, day by day, in the battle with a faceless enemy who moves along undefined lines.